Welcome to a lesson with Dr. Pal. Let's talk about an application of using a characteristic polynomial, um, which is a multiple of the minimal polynomial associated with the matrix. We're going to take a 2 by 2 matrix right here, and we're going to raise it to the 5th power using the characteristic polynomial. How are we going to do that? Well, let's think about this matrix as being representable as a scalar x to the 5th. And if we think about it, if p of x is our characteristic polynomial, it's a determinant of this, which has degree 2 even. Think about what happens if we were to divide our our characteristic polynomial, which acts as 0 as a scalar, into x to the 5th. We would have a quotient. We would have a remainder. And if we rewrite x to the 5th as the characteristic polynomial times the quotient plus the remainder, realize that this matrix right here, or this scalar right here, x squared minus x minus 2, is actually the 0 matrix, or it's like a 0 scalar. So if you multiply it by anything else, it's still 0. So this is just, in fact, quite literally equal to 0. So all you're left with is the remainder. So x to the 5th, quite literally, is just the remainder. The remainder has degree less than what you're dividing by, so it's going to have degree 1. It's going to be like ax plus b. Wow. So x to the 5th is the same as ax plus b. This is a lot simpler to compute than x to the 5th is. What is this? This is like this is a scalar, like a real number even, times your matrix plus a scalar times the identity matrix. That's it. And so we just need to figure out what that is by doing a little polynomial division here. Okay, so let's do that. And what we're going to do is we're going to use generalized synthetic division to do that. Now, wait a minute. How in the world is that going to happen? Because, I mean, synthetic division usually happens when you have like 1 times x plus or minus a number right here. Right? This is an example of what you call a monic polynomial, meaning that the leading term has a coefficient of positive 1. Well, we can do the same thing here because, in fact, all characteristic polynomials are always monic, which is kind of a nice thing. 1 times, just because of that fact, we can use a generalized synthetic division to go fairly quickly. So let's talk about how that works. First of all, we're dividing into x to the 5th. Let's write out the coefficients for x to the 5th. So 1 x to the 5th, 0 x to the 4th, 0 x cubed, 0 x squared, 0 x, and 0. Okay, now let's write out right here these guys, the coefficients right here of the divisor, but we ignore this one, but we look at these two. So with regular synthetic division, like, x minus 1, we'd only look at that guy, right? Well, here we have 2 to look at, and it's not much different than the other synthetic division process. So just like with regular synthetic division, when you look at this in the divisor, you change its sign. So say like 1, and then if you had a lot, this same setup, then you'd say, you drop that guy, you multiply 1 times 1, you put it there, you drop, you add, you multiply, and so forth, and you go down that way. So it's going to be similar to this. In fact, it's roughly about the same, except we just have two things right here, but it's not too bad. So what you do is you take these coefficients, which are -1 and -2, and we're just going to negate them, just like we do here. For synthetic division, we're always going to negate them. So we negate them, so -1, -2, but we write it as 1, 2. So we just change their signs. So think about this as -x, -2 becomes a 1, 2. And we write down 1, 2. So this is the setup, and we're ready to go. How does it work? Well, it begins the same way. You drop the 1 down here. Then you take 1, and you're going to multiply it to both of these. And where are you going to put it? So let's see where it goes. 1 times 1 we'll put right here. 1 times 2 we'll put right there. Notice how we have two things going on right here. So 1, 2. Okay, now what do? Then we just add in this column to get us a 1, and we repeat. 1 times this one, we put here. 1 times that 2, we put there. Then we add 3. Okay. Then we say 3 times that one is right there. 3 times that 2 is right there. Then we add 5. Then we say 5 times that one is right there. 5 times that 2 is right there. Then we add. And we can't repeat because we can't go over here. So we're done. Then we just add right there 10. And see how we have two things here? That means we have two things here for a remainder. So remainder is, in fact, we have this quite literally, is 11x plus 10. Wow. So x to the fifth is just 11x plus 10. In this case, if x is thought of as a matrix, it's kind of neat, actually. Thinking of x as a matrix, you have this equality right here. And it all was because the characteristic polynomial behaves like 0, or actually is the 0 matrix. So let's take a look and remember what our matrix is. It's 0, 2, 1, 1. So we have 0, 2, 1, 1. 11 times that matrix plus 10 times the identity matrix is our matrix raised to the fifth power. So this would be 0, 22, 11, 11 plus 10, 10. And we end up getting 10, 22, 11, and 21. And that is our matrix raised to the fifth power. Thanks for watching.